Hey, hello. My name is Daniel Yuschick, and I really want to say thank you for anyone who is there. I obviously can't see you. I hope there's a few of you there interested in what we're going to talk about today. I said this last year that I really hope to be there in person this year. Wasn't able to make it happen, so thank you to Rendercon for still allowing me to send this talk recorded this way and still contribute to this conference. What we'll be talking about today are our components, whether we're building standalone components, working within like a component library, or working on like a larger design system. Components are at the core of so much of front-end web development at this point. And we're going to look at ways to build better components in order to create more resilient front ends to change and support changes, support products as they scale. So first here, I want to provide a QR code. If you scan this code, you're going to download a PDF from Dropbox and get all the slides for today's talk. A nice little bonus is if you download the slides today, you're going to get an extra section in those slides that I cut from the talk because we just don't have enough time to cover everything today. But in the slides, you have everything. You have all the content. So you'll get an extra section in the slides today if you download them from this QR code. So while you do that, I'll introduce myself. Like I said, my name is Daniel Yuschick. I come from a design background, but have been working in the front end for about 15 years now. Over that time, I really developed a passion for accessibility and brought that into specialization in design systems. I've stepped into a lot of different code bases with, standalone single components to kind of an internal component library, and I've worked within and helped architect and build multiple design systems as well. So I bring a lot of that experience into this talk and try and highlight different ways that components break down over time and show alternatives to how we can build components resilient to those changes. I'll give everyone one more second to download the QR code here just in case. If not, I'll send the slides to the organizers. They'll be able to distribute them if need be. But yeah. More recently, I work as a lead design systems developer at SAP Build Apps. It's a subsidiary within the full SAP umbrella, and spend some time mentoring at a local organization here in Helsinki, helping junior developers and people looking to get into the development field. So I kind of mentioned it already, but our goals for today are going to be identifying patterns in components that break down over time, whether content changes, product scale, teams change, patterns within components that tend to just not hold up and create technical debt. We'll then learn alternatives to those patterns that tend to hold up more resiliently over time, be more resilient to change, and support changes within a product, changes within a team. So one thing to note here is that the code samples we'll be looking at are going to be done in TypeScript and React. A lot of the concepts are transferable to other frameworks, whether you're working in Vue or Angular or whatever else. But at least for today, what we're looking at are going to be samples within React and TypeScript. So how we're going to achieve these goals are by first looking at our TypeScript interfaces. We're going to learn multiple ways to manage these interfaces better to be, again, more resilient to change, more extendable, and easier to manage. Then we're going to look at some React conventions and how we actually structure our components themselves. Then I'm going to be throwing a lot of stuff at you, so we're going to do a quick recap at the end where we just hit all the key points again just to drive them home and just highlight each thing once more. So that's the layout of what we're going to go over today. I think we can just kind of get into it, right? So let's start with our interface management within TypeScript. How do we make the most out of our component APIs? So we're going to start with the first section here, kind of a light entrance here. Keep it pretty simple. And that is grouping similar props. So one thing to note is the majority of the code samples you're going to see today are going to be live production code samples that I've taken from production code bases over my career, essentially, to highlight how these conventions are actually used, and to say, hey, I'm not just like making everything up just to serve a purpose here. The majority of the code examples you're seeing today are going to be real live production things that are out in the wild right now. And we're going to start with this input interface. Now, this is a subset of the entire interface of this input, but we're going to look at these 5 specific props first. We have our floating label, show label, is dark, and then is large and is small. Right? We have 5 props to manage the appearance of this input. So as we need to add more, maybe themes or sizes, our interface really starts to bloat and get very difficult to manage. So instead, we can take this step back and put these props into categories. In this case, we're going to have label-related props, theme-related props, and our size-related props. When we group these components this way, we're able to simplify the interface and make it much more extendable with an easier learning curve going in. So by grouping these similar props, we create a cleaner and more extendable interface. Here we're using our TypeScript types, and we're going to be using label type, and we give it these string literals of fixed, floating, and hidden. And then we do the same thing for our size and theme, and we also define our default values here as well. But by organizing our input interface this way, we take those 5 props and we compile them down into three categories, and we just define the values with the string literals here. And a nice thing about this convention is, how, as I said on the previous slide, eventually we're going to need to add a different size, like an XS, or we may need to add a different theme, like a high contrast theme. So instead of adding additional props entirely to our interface, we can now extend this component by just adding the new XS string literal, as well as the high contrast value to our theme prop as well. So whenever our component needs change, we're able to extend them without really bloating or affecting the interface. We're able to keep the props the same because they're just the categories of values. And then we're able to add new category or new values to those categories without really making the interface larger, making it more difficult to get into. You have fewer props to remember, and then you let your values be pretty explicit and clear. So by grouping our props into these categories this way, we create interfaces that are far cleaner, far easier to manage and extend. We can look at another example here of the button. Again, we have different variants, different shapes. We have a level of primary, secondary. We often see buttons that have props like is full width or does fit content. We have different shapes and variants. By using the category approach, we're able to have fewer props that we can add different levels, shapes, variants to, again, without really bloating or making the interface more difficult to manage. I think we can look at this another way, though. Just have an analogy. Just look at this a different way, just to drive the point home. In the beginning, we had New Kids on the Block. And that slowly led to Take That and Westlife. And then it kind of slowed down a little bit before we had Backstreet Boys and NSYNC, which then created a flurry of 98 Degrees, LFO, and O-Town. Then it slowed down a little bit more before One Direction came out, and then we had BTS, which took over the world, right? This is an example of how something that may seem really simple and small and contained to start can really quickly blow up to be very complex, difficult to manage and understand, and become just way too much. Now, to be fair, the boy bands are not an example of that, but let's look at another TypeScript example of one of those instances. So a common pattern I see on input components like this is we'll have 2 props that I like to call data gate. We have the data of an error message, which is a string, and then we have the gate of has error, which is just a Boolean. So we have our data gate props. So if you have these 2 props, it doesn't seem like it's too much to manage. But if you have several instances, you're essentially creating 2 props for every one value you need to use. So in this case, if we have this error message and has error props on our input, we would do something like this in our JSX, where we would say has error, then we'd show the span with the error message, and if not, we would show whatever else or nothing. So we have two props to manage essentially this one thing. Instead, we can simplify our interfaces and group the two datagate props into just one data prop. So here, we're making I believe, a safe assumption that if we have an error message on our input, we can assume that the input should be in its error state. So whether we change the border color, manage or have the focus management, bring focus back to that input, whatever logic we need to tie to the error state, we can control by just having the single error message prop and get rid of the has error boolean. And then in this case, we can just check if there's an error message, show the error message. So then we're able to simplify, again, the interface and just pull all of our logic off of that one data prop. And by that, we're able to group the two data gate props into one and still have the same functionality with, again, a cleaner, more extendable interface. And that is grouping similar props. Which brings us into our next key, which conveniently is consistency is key. This might be my favorite one. So I think this is maybe the most, when I come into a new code base, this is usually the first thing that I notice that can be improved. And the core concept that we're going to look at, and the core point I want you to take away today with this, is that if you know how to use one component, you should know how to intuitively use another. And by creating consistent patterns and conventions, you don't have to learn the specific components, but you just have to know the conventions, and you can apply those across different components within the code base. We'll look at this example here of a button. And we'll then compare this to a switch. You see they have similar props, like the loading, disabled, is loading. And while they both have the same size prop, the values of that size prop are different. We have the 2-letter t-shirt sizes, and then we have the full word size as well. So we have two components within the same code base that are dramatically different in their conventions. And this happens far more often than you may think. It's really easy to have this happen. Developers are notorious for changing jobs, right? So one developer may build the button, and then a new developer comes in and builds a switch, and there's no documented conventions or patterns to follow. So each developer just builds the components to the way that they, the way that they prefer. It could just be a big team that doesn't communicate very well. It could be a startup that's moving really fast. This happens really easily, and it's not necessarily a thing that's like bad or like a frowned up or like looks bad, like poorly upon the developers. Like it's sometimes just the cause of the situation, essentially. But we can take a step back and define some conventions to make sure that we can use one component and transfer those conventions over to another component. So we're going to continue looking at the button and switch, but we're going to now add in an icon, which maybe breaks this convention of controls of a button and switch. Now we have an icon that's just visual. But by defining our conventions for how we name our props and name our values, we're able to take the same conventions that we use with the button and apply those to both the icon and the switch as well. So we have the same is busy, is disabled convention across our button and our switch and probably other inputs and controls as well. And they each also have a size prop, and all of them use the 2-letter t-shirt size values. So even though the icon has a different excess value available to it, like they use the same values, they use the same conventions. So even though they have different values available to them, they use the same convention, so you can intuitively understand that if you need an extra small icon, it's probably going to be excess. So by defining these conventions, we're able to learn how the button works and transfer that knowledge over into the icon and switch input and everything else. We can intuitively know how to use other components based on how the one component works. But this goes beyond just props and their values. We want to make sure we're using the same defaults across components as well. So again, looking at the button interface, the button, icon, and switch, all three of them have the same size prop. So in this case, when we're using the same size prop, we want to make sure that size on all these components has the same default value applied to it. So I like to say that medium in the components that I build, I like to say medium is the default size for everything. If any component has a size prop on it, the default will always be medium. And it creates this expectation, a reliable expectation that if you know how one default value works for one prop, you can assume that another component that has the same prop is going to have the same default as well. So whether we're working with a button or an icon or a switch, we're all dealing with the same default size of medium for each of them. And it's important that we're not learning how each individual component works. We're not learning the components. We're learning the conventions. And once you know conventions, you can now apply those to different components throughout the code base, no matter how much it scales and how much it turns over. If you know the conventions, you know the components. This does extend beyond just code side. This isn't just a developer's job to manage. It takes a lot of collaboration with design as well. We want to make sure that if we're using the same prop values within our components, that the same prop values are going to create a consistency within the UI as well. So in this example here, we have inputs and buttons paired together that are all three different sizes, small, medium, and large, right? And we want to make sure that if we're using the same size prop on these different components, that we're going to create a UI that is also consistent and can be paired together. But this can't just be done on the dev side. You have to collaborate across teams to make sure that there's consistency in both the code and the design. So when we collaborate across teams this way, we're able to create not only just consistency within the code side, but that code side consistency maps to consistency within the design side as well. So now, when we render out our small input next to a small button, our large input next to a large button, we get a UI that is consistent and does flow and pairs well together. But you have to collaborate to keep this consistency and to work on this with both design and development. So with that, we wrap up consistency is key. And we'll move into the third key now, which is don't reinvent HTML. I'm going to assume that just about everyone in the room is either a front-end developer or a full-stack developer that works on the front end. In any event, we should all know, if we work on the front end, we should all know HTML. It's a universal thing that pretty much every digital product is built upon that renders at the end of the day. We should all leverage that shared knowledge of HTML within our components. Because when we deviate from the conventions and patterns defined in HTML, we create a new nuance that we not only have to remake ourselves as devs, but now we also have to relearn on the implementation side. HTML was created by a ton of different people who are all far smarter than I am. Why would I think I should go in and create my own version of HTML just to support my own components this way? We want to make sure that when we're building our components, we leverage the shared knowledge and shared experience of HTML within them. Now, it requires a whole other talk or a whole other article about sort of the maybe not deep knowledge of HTML across a bunch of different developers. I think that's kind of its own problem, but if you're working on the front end, you should have a strong grasp of HTML. And when you have that strong grasp, you can leverage that with your components and make the entry point for them a lot easier to manage. It might be easier once I show some demos here and explain. So we're going to pick on the input again. So let's say you're in a brand new startup, brand new product, everything's cool. The designer comes and says, hey, here's our input component. These are its states. It's inactive, is active, disabled, and error states, right? So, me as the dev, just awesome. Let me just put together a quick interface for this. Cool. And now with this interface, I'm able to create and match the designs that were provided for these inputs. Terrific. Awesome. Ship it, right? We're done. One small thing to note before moving forward is this onChange event handler prop. We're going to come back to that one, but for right now, let's just keep that in the back of our mind. because our input works. Our input component works, it matches the designs, and everything's cool. And then some time passes, and product changes, the requirements change, and now design says, hey, we now need these different variations. We now have a login support that we need to have a password field. We need date of birth content. We need a search field, phone number field. We now need our input to handle these different variations, these different instances. And this is normal. A product changes, the requirements change, your components have to change with them. So we get these new requirements, and I say, all right, cool. Start putting the interface together for our input. We add the number type here, and we have our min and max lengths and everything. I was like, okay, cool. But then more requirements come in, and before you know it, your interface starts to look like this. And a reminder that this is an example of code that I've taken from a live production code base that's shipped, that's out there, that's in a product real time right now. This is an actual component interface that's out there. And I look at this interface, and it's just, tell me why. Why did it get to this point? And why our interface became this bloated and this impossible to manage is because we didn't treat HTML attributes and component props as two different things, and we should. They are two different things. We want to leverage the shared knowledge of HTML attributes and only create custom component props where needed. We don't want to overwrite HTML and reinvent it. We already know it, should already know it. So our interfaces should only pertain to the custom props that are specific to that component. So if we take this approach, we get a much cleaner interface here. We only have the description field, the error message field, our input size, maybe some slots, theme, variant. We have a much more simplified interface for our input. And it's all predicated on this one line, where again, I'm coming from TypeScript and React world, where we're able to extend the native HTML attributes of an element. And whenever we do this, we now have access to everything that's in the HTML spec. We don't have to reinvent it ourselves. So now our component interface can just be for the component props that the component itself needs. HTML is inherited. We should know that. We don't need to change it. We don't need to reinvent it. Let's just have our interfaces be props specific to our components. We're going to look at another example here that I think is maybe one of the most common deviations from HTML conventions. And that is the button, the classic, wonderful button. In this case, we have, again, maybe a brand new product. We have a very simplified interface. So we have a button in our UI, and we just provide a text prop. The content of this button will forever and always be a string, so just make text a string, and that's just going to be the prop on the button. So in this case, to create the send message button, we just pass in text equals send message, right? Great, ship it, it works, right? Until it doesn't work. And design comes in and says, hey, we want to now manage our loading states to now say sending message in italic text and have the little progress dots after the text itself. And now with this one, I would consider a relatively simple change on the design side to have the loading state this way. This one simple change has completely broken our component. And it broke our component because we deviated from the conventions that we all know from HTML. And to better explain this, I think we should take a step back and we should ask ourselves, what is a button in HTML? And if you take away the browser-specific styling that they have on buttons, what you're left with is essentially just a semantic container that's interactive. HTML doesn't care what you put inside of that container. You can put anything you want in there. You shouldn't, but you can. That's the beauty and the curse of HTML. You can have all the flexibility in the world, but may end up shooting yourself in the foot. But if we use this convention of HTML that a button is nothing but a semantic container that's interactive, and it doesn't care what's within that container, if we take that same convention and move that into our button component, we can now support that design. Again, here we're going to extend the native HTML button attributes. And what this does offer us then is access to the children prop, or just the content within the button. So now instead of putting all the content for the button as a single prop on the button component, the button component can now support children within it. And in this pseudocode example here, we just have a generic isSending prop, or isSending variable. And whenever the message in this case is sending, we'll show the sending loading state, sending message, whichever. We would have some styles on this, but we can now manage the content of this button in a flexible way, the way that we would expect from if we were doing it in HTML. If we were building this button in HTML, we'd be able to do exactly this. But as soon as we introduce that text prop, we break that convention, and then our component breaks as a result of that. So by leveraging the conventions that we know from HTML, we're able to now create a button that is far more flexible and can accommodate our designs. And I did mention that we would come back to this one onChange event handler. This is if the text prop on buttons is the most common thing I see, this onChange event handler is the second most common thing I see. When we look at this event handler here on this prop, we have onChange, fine, and we're passing in a value of string, right? So anytime that we're going to use this input and we want to listen to the onChange event handler, we're always going to receive the value, which is great. Like 80% of the time, maybe. But those other 20% of the times, we may need something like the key code. We may need a sibling or parent element. We may need something else other than the value. And where this breaks down is when we're working with native JavaScript and HTML, this onChange event handler sends the event. So whenever we're dealing with this in native HTML and JavaScript, we get the full event object. We get all the key codes, we get all the siblings of parent elements, we get the value, we get everything on that entire event. So this is a very common thing where we try to just say, oh, we're always going to just need the value of the onChange event handler. So we just overwrite this onChange handler within our props, pass in the value. Terrific, right? Like I said, that's maybe 80% of the time you may just need this. You may just need the value, but the other 20% of the time you may need something else, and this component breaks down. So what do? Do you update this onChange event prop on this input? Because if you have a pretty large code base, that's a really heavy refactor to go through every place that you're using the input and update this onChange event to then just send event or target value, event.target.value, whatever, a beautiful time to blank on the actual object. But we would have to go through the entire code base and refactor every instance of this to now send the value manually instead of the event just to support this one use case. Maybe we deprecate this component and create input v2 that just inherits the onChange event and passes the whole event. But now you have terrible technical debt, again, if you have a very large code base where you have all the deprecated inputs everywhere, that you now have to gradually refactor as you go, which, well, it's not going to happen. We're never going to get to it. So we don't want to break that convention of HTML, and in this case JavaScript, and reinvent it ourselves. So instead, we want to use TypeScript and again, inherit and extend those native attributes that we all use and expect. So now when we extend the input attributes, we get access to that onChange event, and it's going to send the entire event. Yes, 80% of the time you're going to just use the value, right? It's going to be fine. But the other 20% of the time where you need something else, by extending the native behavior and not reinventing it yourself, you now have access to that, and you have a component that is resilient to those 20% of instances where you need something else than just the value. So that's don't reinvent HTML. Those are the 3 points we're going to look at today for TypeScript interface management. And with those, you apply those to your work, and you can really, say goodbye to bloated, unmanageable interfaces for your components. I guess I should say, I'm going to say bye, bye, bye to them. My bad. So that's how we manage our TypeScript interfaces. So now we want to take a look at our component patterns within React. How do we enable flexible design and create resilient development within our components themselves? We're going to look at two main keys here. And we're going to start with the first one of component composition. I think this one is perhaps a bit more common, maybe a bit more familiar to some people, but we're still going to spend some time on it because I think it's immensely valuable for particularly complex components. So here, we're going to take a look at a basic dialog, like a confirm dialog, for example. In some of these examples, we have one action or two actions. We might have a close icon, or in the last example, we have a header image and we have a checkbox in the action. So like we have a lot of variants of this one dialog component. So let's walk through maybe how we would approach building this from the simplest version to the most complex version and sort of see how our component interfaces and the actual component structure in React scales to these variations. So we're going to look at the simple action first, and yeah, we're going to look at the interface here. And we may have a simple action prop on here that has the callback or the handler and the label. We have the content and on close to create the close icon and the title. So with this interface, we're now able to build this version of the dialog. And in React, it would look something like this. So we would create this dialog this way. We'd pass in our handle click with OK action and the whoops title and all that stuff. And yeah, so we're all good. But then a new need for the product happens, and design has to evolve to accommodate that change. And now we have a dialog that has a secondary action, in this case, a cancel action. And because we have this cancel action, we've removed the close icon from the dialog itself. So this is the interface that we had started with one action, on close, all of that. So we may update that interface to look something like this, where we have a single action type of handler and label. And now we update our interface to not support an action, but to support an actions, where we can pass in either one or an optional second action within this array. And now we're taking the required onClose prop and we're marking it optional. If we don't pass onClose there, we're not going to show the close icon. Okay, great. Right, so we have the actions within the actions prop, and we have onClose as optional. Again, depending on the size of the code base, this may require a bit of refactoring to handle this. But now with this updated interface and the updated approach to our actual component within React, yeah, we're now able to support this use case. Until design comes, shows the third variation, and you're just like, quit playing games with my heart. Like, I can't do this, right? I can't make this work. How do I use the same dialog component and create this variation of it? So now what you're going to see a lot is this might be a custom dialog. The place I'm coming from, work-wise, like we have a ton of dialogues and pop-ups and stuff like that, and the process of unifying those throughout the design and the code was just a months long effort to do and unify. And even still, we're still creating custom one-off dialogues, I would say, quite regularly. It's a very difficult thing to manage. And why I think it's difficult to manage is our components are essentially trying to take care of the content and not themselves. The best components are selfish. So again, if you downloaded the slides, this slide includes a link to an article I wrote on Smashing Magazine that follows the same concept, that the key to good component design is selfishness. We want components that don't worry about their content. We want components that are only worried about themselves. So when we see this dialogue now in the design, we don't see a single unified dialogue. No, we see a dialogue that has a close, has a header, content, and footer. We see a dialog that's comprised of 4 separate components, all within the one package of the dialog component. So when we apply this concept to our dialog in this case, and we manage it with 4 smaller child components, we now create a whole lot more flexibility. So now we're going to create this first example by using the parent dialog component. And then we have the child dialog header, close, content, footer components that all take care of themselves. We can really leverage CSS to manage our layouts and manage our styles for kind of these variable layouts this way. But as soon as our previous dialog had to start accounting for its own content, it would break down. So we want to make that component selfish, only care about itself. The dialog should only worry about, I don't know, a couple of things. Laying on top of all the other content, which if you use the native HTML dialog element now, that takes care of it for you. And positioning itself, whether you want to be centered, full screen, like whatever. Those are really the only things the dialog should really care about. Oh, and also, is it even visible? So 3 things. The dialog should care about 3 things. Let the header of the dialog care about what's inside the header. Let the close button worry about whether it should be there or not. Let the content worry about its own content. Let the footer worry about its own actions. So now with this concept, if we want to, let's say, remove the close icon from this dialog, we just don't include it in the JSX. And then the UI is going to adapt. We don't have to update the interface for our dialog to now support this. If you don't want a close icon, don't put the close icon in there. So by using component composition, we're able to move the content responsibilities from the parent dialog down to kind of the content levels themselves. Now we can do this component composition layout or convention generally like this, where we would have our main dialog component, and then we would have the header, the close, the footer, all that stuff. We would have all of those be separate child components that we then add on, like dialog.close equals our close component. Dialog.content equals our content component. We can use this convention to create chained composable components, and I find this most common with the dialog. So now, when we use this component composition convention, we can look at the final example of this dialog, and now we just see a header, content, and footer. We don't see a single dialog that has to take care of this content. We see a single dialog that contains a header, content, and footer. So with this convention now, we just use the dialog header, we pass in our image, done. We have the dialog content, we pass in our header, our content, done, right? And then we have our dialog footer, we pass in our checkbox, our button, and we're good to go, right? This way, the dialog isn't concerned with its own content. The dialog only cares about itself. Let the header worry about itself. Let the content worry about itself. Let the footer worry about itself. Components that are responsible for their children or for their content will break down because content will forever and always change. Products always change. Content always changes. So when our components are responsible for that content and our interfaces are responsible for that content, they're going to break down because content forever and always changes. So we want to make selfish components that only really care about themselves and create this composable approach to our components so that we can alleviate the responsibility of that content to the lowest level within it. And with that, we're able to create composable components. Which brings us to our final point for today, which is component stores. This is a convention I learned from I guess maybe component library called AriaKit. If you haven't heard of it, it's worth checking out. It's called AriaKit. It's incredibly well done, incredibly flexible, focus on accessibility, really, really good stuff. And that's where I learned this concept. And the core of this concept of component stores is that you're able to keep components in sync across different parts of both the UI and the code itself. You're able to keep a single component in sync across multiple places in the code. For this concept, we're going to take a look at the classic popover menu. You have a hamburger menu, hamburger icon button, and it pops out the menu with some options in there. So we're going to take a look at this popover and see how our component store approach can work with this component. So with React, we're going to create a use popover menu hook, which is going to return us the component store. Then once we have that component store, and that store is going to contain all of the logic and functionality needed to power and manage that menu. Once we have that store, we're going to pass that into the button that triggers that popover menu. And we're going to pass that into the popover menu component itself. So now the button and the popover menu are in sync together. We're gonna look at a bunch of code to break this down. So here we have the first example of the use popover menu hook. Within this hook, we're going to handle all the logic like the show and hide states. We're going to handle all the keyboard support. And once we have all that logic done, we're going to return a single store object that can manage this popover menu, which is going to look something like this. So we have the menu is open state hook here. And then we have the menu trigger ref. And with these two pieces, we're now able to return a store that has the actions and the state of the popover menu. We have the open and close states or the open and close actions of the popover menu, and then we have the menu is open state value as well as the menu trigger ref. And I'm going to show you why that's important next. But we have this example of the hook, and we're going to return this basic store from this hook that manages this popover menu. So now this is a lot of code. We're going to break it down into the 3 core steps. First, we're going to create the store. We're going to call the use popover menu, which is going to return the store to us, and this store is going to manage that particular instance of the popover menu. So once we have the store that again has access to all the actions and state of the popover menu, we're going to pass this now into our icon button that toggles the popover menu. So now our onClick points to the store.actions.open, or perhaps store.actions.toggle if we want to have that. But then we pass in the ref of the menu trigger ref from, again, the store.state.menuTrigger ref. And now with this ref, in the hook side, we're able to apply all the accessibility properties that we would need on that button. We take that requirement out from the implementation side. And now whenever we have that ref within the hook, we're able now to take that ref and add ARIA controls, attributes, and all that stuff to it to manage the accessibility of this trigger ref button. And now just having references to the store like this on the icon button isn't going to do very much. So now we're going to pass the store itself into the popover menu. And with that, the icon button that has access to the store.actions.open is now going to refer to the popover menu that has the exact same store passed into it. So if we imagine like a header bar that has maybe a profile menu and a debug menu and an admin menu, they might all be 3 separate popover menus. But by managing the single instance of the store, we can have multiple popover menus in the same UI and not have them conflict because our buttons and our popover menus are using the one shared instance of a store to manage itself. Well, we can do a bit more with this. We can take this further and we can show that the component store can actually act as like the entry point for the component itself for any type of customization or modification of that component. So in this example here, we're going to pass in to our use popover menu hook. We can now pass in an onClose callback, an onOpen callback, or a placement prop. And now we pass that stuff into our hook, and our hook can now manage all of that for us. It can manage our placement, or in this case, we can have a new handle open function where we call the optional callback, but then we set the menu to open. And now our store, whenever we call actions.open, that's going to point to our new handle open function, which is going to handle the optional callback that we can pass in. We can treat the store as the entry point into the component to customize and modify its behavior. Another place I like to use this approach is with tabs. You know, we have the tab bar and all the tab panels, but that sort of breaks down into just a parent component and a child component. So we can use or create a use tabs hook that manages all the tab IDs on the buttons to associate them with the corresponding panel. We can manage all the accessible keyboard support requirements and focus states, and then we can export that out into a single store that we can now use between the tab bar and the tab panel, which very often live in different parts of the code base. And with that, we're able to create one singular store for the tabs and manage them across two different parts of the UI and two different parts of the code base by sharing that one single store that has access to all the management of that one component. And that is component stores. So like I said, I feel like I threw a lot out there. Repetition is the key to learning, I think. So we're going to recap each key point again, just to drive each point home. So we first looked at interface management in TypeScript, where we learned that we can group similar props into categories and allow those props to be more extendable to changes in the future. Then we have consistency is key. We want to define conventions for our components, so we only have to learn the conventions, we don't have to learn the components themselves. So ensuring that we're using the same naming conventions for our prop names, our values, using the same defaults across components, and making sure that we're collaborating with the design side as well to create a consistency within the UI. So we have a shared consistency across the code and the design both. Then we looked at don't reinvent HTML. We want to leverage the shared knowledge of HTML and handle HTML attributes separately from component props. If you downloaded the slides, you're going to get one more key in here. But for now, we're going to move then to the component patterns in React, which look at component composition. The key to good component design is selfishness. Components only should care about themselves. Let the content handle itself, because content will forever and always change. So components that are responsible for managing that content will break down. So instead, we want to create selfish components that let the content do its own thing. And lastly, we looked at component stores. Creating a hook that returns a store to manage that component and keep it in sync across different parts of the UI and the code base as well. Again, you can reference the component library ARIA kit to see this in even better detail, better examples. Component stores allow you to keep a single component in sync across different parts of the UI and the code base. I think it's important that we're not just building components here. It's really easy to maybe just get a little siloed and have blinders on and just see that we're building components, but I see it much larger than that. We're building trust. We're building trust between teams like design, product, development, QA. We're building trust within teams that our components are going to not just work the way that are expected on the QA side, that are not just accessible the way that we're expecting on the product side, that look the way that they're supposed to look on the design side. We're building trust across teams by building these components. And that trust across teams leads to trust within an organization, within an entire product. Components, a single button seems very insignificant, but if we approach it the right way, we're able to essentially build trust within an entire team, organization, company by having resilient, reliable components. Which does bring with it one disclaimer I want to address. One disclaimer, because everything good always comes with a catch, right? It depends. Every one of these approaches we looked at today may not fit every single component you're going to build. They might fit most, but they may not fit every single component you build, and all of them may not fit at the same time. So it depends when you're going to use these, but if you use these keys and use these approaches in your components, you're going to find much more resiliency to change, and you're going to find much more trust between design and development and throughout. But you aren't forced to use every single convention in every single component till the end of time. Use it as it depends. Each situation is going to be a little bit different than the next. It depends when to use these, but like I said, in my experience, working with design systems, being around for 15 years, I feel confident that these are keys that can benefit a product. These are keys that I use in my work just about every day whenever I'm building components. but it depends when you use them, but you should get value out of them as you need them. And with that, I want to say thank you. You hung in here. Thank you so much for attending. I hope you found something valuable in this talk. I hope you're able to download the slides. Like I said, if not, I'll send them to the organizers as well, and they should be able to distribute them as needed. Let's connect on LinkedIn. My name is Daniel Yuschick. If we connect on LinkedIn, I'm happy to take any of your questions. Happy to chat further about this. Like, this is the stuff that I do. It's the stuff that I really enjoy, like components and UI work. Let's connect. Send a message. Say, hey, ask any questions you have if you have follow-ups or any questions, concerns, anything like that. I'm always happy to talk about this stuff and work with other people. So let's connect. Let's stay in touch. And then, fingers crossed, next year, Rendercon, if you'll have me, I will find a way to be there next year. Third time's a charm. We'll make it work. I really want to be there in person and be just like a really small part of that community. That is, yeah, I find that like really important. Something that I would want to do and think is just would be really nice to do. So I'm hoping to be there. I'll do everything I can next year if you'll have me. And until then, let's connect on LinkedIn and let's build better components together. So one last time, thank you to everybody who attended, who hung out this whole time. Let's stay in touch, and I hope to talk to you soon. I'll see y'all. Bye.